friends, we are here and Uwe Ricken is online from Germany, and he is going to talk about user-defined functions. Watch his demos. His demos are amazing, and I really love the way he presents and the concepts. Uwe is a long-time SQL expert. He is a Microsoft certified master. Just like me, we both are NCM. So, you know, that rare breed of NCMs, about less than 200. So very lucky there, both of us. We both are MVPs also. And Uwe has been working in IT systems since 90s. And SQL Server, of course, is his core area of expertise. Uwe, thank you very much from me, our team members, and of course, from the entire community, so that you could take out time and join us for this session. Over to you, Uwe. Thank you.
Yeah. So yeah, thank you very much, Amit. It's a pleasure to speak for such a great audience here. I see we are currently having around 300 people. Hope to see it gets a little bit more. And yeah, let's start it. It's about user-defined functions, but not only user-defined functions. It's more about the focus on the improvements we have with user-defined functions. This is the great thing here.
Yeah, Uwe, so you will.
Yeah. I have to share it again. Yeah.
Again, and we have another few hundred live on YouTube. Just to let you know. Yeah.
Okay. Yeah. So let me see how I here share it. So, and now it should work.
Yeah, we are able to see your screen. All good.
You see my screen. Okay, so fantastic. Okay, let's go ahead. We are short in time. I closed the door so nobody can escape, especially me. Excuse me that I don't show a video of me. If you have expected it, I have a big problem. I'm sitting here in my pajama because I'm coming right out of the bed. It's 10:30 here in Germany, and usually I wake up at 11. So I didn't have the time to pull on my clothes and to shave. So that's the reason why I don't have video here. Let's go. User-defined functions. Before we start with the improvements of user-defined functions, first of all, please let me thank you, the knowledge partners, because I think that everybody of you is aware of, if you don't have sponsors for such a big event, it would definitely be impossible to have this quality of event. So thank you to them, and thank you to Amit again for his engagement here. If you want to download the demo database, here is the link, but don't worry, I will upload the presentation and then you can download it afterwards. That's me, that's only commercial, so forget about this. The only thing what I would like to mention is my email address. That's a true address. So if you have any questions concerning user-defined functions, or especially the SQL Server database engine, feel free to drop me an email. I would really be happy to answer all your questions about that, if it's possible. This is our agenda, very simple, very easy. First of all, we start with the basic definition. What is a user-defined function? We come to the limitations of user-defined functions, and then the biggest problems we have here to the different types of user-defined functions. What we have three of them. Then we come to the problems, which basically occur with every user-defined function. Just only one is perfect good, but two others are bad. And then Microsoft SQL Server, the Microsoft team came with so great improvements since 2017. It's really amazing. And I want to show you in demos how these improvements are working. So user-defined functions are available since Microsoft SQL Server 2000. With SQL 2000, that many developers thought, my goodness, that is a cool thing. We want to have this. We wanted to have this. And yeah, what did they do? They tried it heavily, and then the problems for the DBA started. And the functions in SQL Server are like functions in programming languages. User-defined functions are routines that can accept parameters. So whenever you want to run a, let's say, a calculation, just for example, anything like that, you could do this in T-SQL, or because you want to have a dedicated function for that, you encapsulate it in a function, and then you call the function in your SQL statement. That was a really cool thing. Everybody wanted to have it. By the way, I was in the same mood. I was developing lots of them, and then I was wondering about the decreased performance. They can perform an action, such a complex calculation, or what they can do is they can return a separate value or a result set. And that was, for me, the greatest benefits of these functions. That the return value can be a single scalar value, or it could be can be a result set. Primarily, user-defined functions get implemented by developers because of the reusability of code. Think about the following idea behind it. Let's say you have an OLTP system with a customer database and you want to create rankings for your customers based on different calculations. Let's say you have an A, B, and C category for your customers. So what you can do is you can create views where you calculate these categories with native T-SQL. Would be great. The biggest problem with that is that you have, whenever you want to have this category inside your view or your views, you have to put this calculation in really every single view. So what will you do then? In that case, what I would do is, hey, let's create a function which calculates based on arguments the category of the customer, and then I put only this function in the output of the views. The good thing here is when you do this and you decide to, let's say, to implement another category, you only change the function. And you change the function, automatically all the calculated values in your views will be recalculated. That's a great thing. They allow modular programming. They can, and this is very important, they can allow faster execution. Let's see the can, which is in bold, okay? T-SQL user-defined functions reduce the compilation cost of the T-SQL code by caching the plans. SCALAR function, which is not part here of this session, they can really offer significant performance advantages, especially for string concatenation and all this kind of stuff. T-SQL functions are better suited for data access intensive logic. They can reduce network traffic. That's definitely true. An operation that filters data based on some complex constraints that cannot be expressed in a single Scala expression, that can be expressed in a function. We have two different types of user-defined functions. We have, first of all, Scala functions. Scala functions are very easy to handle. The user-defined Scala functions can only return a single data value of the type defined in the returns clause. For an inline Scala function, the return Scala value is the result of a single statement. Inline Scala functions, whenever you have the chance, that's a good recommendation, whenever you have the possibility, you need to have a Scala function, try to put it as a so-called inline Scala function. What means that you can have only one single select statement in it. It's always better than complex calculations in multi-lines. For a multi-statement Scala function, the function body can contain a series of T-SQL statements, what means that you put all the calculation in different statements, and then you finish it with a return and the value. Bad thing, or not bad, but the problem is you cannot use the following data types, text, n-text, and so on. I skip this, you can read it by yourself. And then the second category of user-defined functions is table-valued functions. Table-valued functions are really great because table-valued functions can be used in T-SQL in joins or in cross and in outer apply. And that gives great benefits because you can hand over parameters, and then based on these parameters, you do the filtering inside the functions. User-defined table-valued functions return a table, but not a single data value. It's always a table. And what you always should do is, and that is really the best recommendation, the best takeaway from this session, try to put everything, really everything what you want to do with functions, try to use inline table valued functions. The inline table valued functions, they don't have a function body. And the table is the result set of a single select statement. Inline functions, think about them as views which can take over a parameter. That is exactly the same. Scalar functions return a single value every single time it is invoked. Please take care of this invoked. It can be used in select statements. It can be called from applications, functions, stored procedures. And what you can do is you can use it as a check validation in a table definition. That is really great. Scalar functions can do complicated math and retrieve values from a select statement. You see on the right side, the typical definition. We define the parameters for the function. That's, you see, after the create or alter function. Then you define the parameters, and afterwards you immediately have to define the return value, the data type of the return value, with the returns as data type. You have to put your code, if it's a multi-line, you have to put all your code in a begin and an end block. Experienced developers like you are, you know it from stored procedures where you put your codes in begin and blocks too. Then you do your math, and the last statement in a Scala function is always a return statement. And that is the typical thing how you work with Scala functions. The biggest problems we have with Scala functions are 2 points. What I saw very often in the field was that developers are using Scala functions in the output. The problem with the output is if you put a Scala function in the output of a select statement, it can cause extreme heavy CPU and IO consumption. Because every single time, for every single row where the function is invoked, it will execute the function. And that will increase dramatically the CPU usage. And you see it here on the screen, I did run it on 4 computers, on 4 CPUs, and you see that all 4 are in heavy load. And that is absolutely a big, big problem. Another problem with Scala function is, let's say you have a query which returns lots of data and SQL Server wants to go in parallel. That means that we take more cores. Whenever you use Scala functions, the execution plan cannot execute in parallel. So you will always get a single threaded plan. And I want to show you how this works. So I hope that you can see all my management studio. Ready to rumble? We start with a demo. Sit down, relax, and see what's going on. Here is the first thing. Excuse me. So I'm here in SQL Server 2019. You can see it here. And my database, I want to show you the behavior of user-defined Scala functions before 2017. Let's go for it. So I set the database, the compatibility level back to 2014. This is the compatibility level 120. And I set the Scala UDF inlining on. This is the thing I want to explain to you later on. And now I prepare my data. So I put a few customers, 75,000 customers, and 3 million orders into I transfer it to my demo table, and here we go. The first thing what you will see here is a typical query. What I see quite often, I want to have the number of orders per year for a customer, for a dedicated customer. And basically you can do it with an inner join, you can do it with a subquery, you can use it with group by. There are lots of different ways how to do that. I have decided for an apply operator. Auto apply is the same as a left join. Apply operator calculates this inside query statement, and then you can use the return, the result set, as a return in your columns here. Let's see how this query will work. By the way, the tables don't have any indexes. The reason I don't have indexes is here to demonstrate how bad SQL Server will handle these queries when you cannot go in parallel. So I execute this query. And basically, I would say, oh my goodness, it was so incredible fast. It was less than 2 seconds for just only one row. If I look to the execution plan, you see what SQL Server is doing. What Microsoft SQL Server is doing, because we are only using the relational model, we can cover everything with relational operators. So we have the table scans, which is absolutely fine so far because no indexes. And what SQL Server was doing is coming back with one row of 75,000. Because we have just only one, we take a nested loop and then we grab the information from the customer orders and we come back with one row. But what you can see here is that SQL Server is doing the operation in parallel. So that does mean we have here the actual number of rows, which is 9, and we have 1, 2, 3, 4 threads. So SQL Server is doing in parallel. Great. And now let's say you as a developer, you want to put this logic in a function. So what you're doing then is this one. I create a function where I hand over the customer ID and the order year. So when I want to have for the customer number 10 for 2019, the number of orders, then I want to calculate it with this function here. So very simple. I execute this. You see here, it does the same query. Huh? Return value is, yeah, count please all orders and put it in a return value, then we return it. So let's go and see how this system works. Before I do this, and this for you as a good developer, you all should do this. If you want to measure the performance of any query, put the statistics time for CPU usage and IO for IO usage on. And let me do this here. Time, come on, I was missing one. This is live, IO on. So I measure the CPU and the IO, and here I run my first query with the function in it. The good thing with the function is I don't need group bys, I don't need apply operators, everything is fine so far. And the second way, I'm executing the set-based operation, and what's going on here? Let's see what SQL Server is doing. Here comes the first. I'm looking for less or equal to 10 customers. So you see, I have exactly the same result set. And when I look to the execution plan, you will see some very curious things. Look to the estimated execution costs. It's just only 1%. And you would say, oh my goodness, functions are so cool. I decreased the runtime by 99%. Yes, you're the hero of the company, you would say. But what you see is a big problem what SQL Server Query Optimizer has with SCALAR functions. The problem is that SQL Server will handle the SCALAR function as a compute SCALAR operation. And what SQL Server then thinks, basically, it doesn't cost anything. And that is the problem. So SQL Server say, well, come on, I just only have 10 rows. And for 10 rows, I need to run a simple function. And that makes it so, by the query optimizer, incredible cheap. So therefore, here we have to scroll through all the rows again and again, millions of rows. And SQL Server is telling me, well, yeah, I have to have way more IO to produce because I need to touch the customer orders table too. So SQL Server say, well, 3 million rows need to be approved and need to be operated. That is incredibly expensive. And that's what you see here. And now please have a look to this, what happens here. You can see here, oh, let's go here. Here is the execution of the SCALAR function. Look to this. What SQL Server is telling me, well, I have 682 IOs. Brilliant, because we only touched the customer orders table. But, and that is important, look to this here. SQL Server was consuming nearby 7 seconds of pure CPU time. And the elapsed time is 3 seconds for this query for only 10 rows. And when we go to the set-based operation, we have way more IOs here, but look to the CPU time. It's only 500 milliseconds, and the query was finished in 600 milliseconds. So it seems to be that the second one, also it was calculated the most expensive part of this execution block here. But SQL Server thinks, well, a function is always cheap. And this is the greatest pitfall you can fall ever in. So make sure that you don't do this. So now, this is a bad thing. For one single row, a function can really be quite fast. But in the moment you have lots of data in your set, you will definitely run into a problem. So we don't have the time for another demo with the perfmon. I skip this. And what I want to explain to you now is the following. Why is a SCALAR function so expensive, especially when you put it in an output or in a where clause? The problem is the call of the function for every single row. So what I want to do is I create an X event. What? Oh, sorry, that is a problem. It's coming from me. I just need to fix it. Sorry. So go for it. And again. So what I'm doing is I have an X event implemented. This X event will track the statements from my calls, and let me show you how it's working, because I want to show to you how it works. I hope that you are familiar with extended events. Otherwise, next year I will do a session about extended events. So refresh it. Here's my track SCALAR functions. What you will see, I only take the data from the ring buffer. I don't store it anywhere. And when you look to the properties, you see what I'm doing here. I only want to see the SP statement starting and finishing. Let's check it here. This is a nightmare. Sorry about it, but it's not my fault. It's Microsoft. So what I'm doing is SP statement completed, SP statement starting, and SQL statement completed and starting. What is the difference? If you want to see when a table valued function, for example, will execute it, it is an SP statement. SP stands for stored procedure, but it covers functions too. SQL statement will cover my statement itself, where I call the user defined function in. So what I do now is I watch live data, and then we go. So I do a procedure cache cleaning, and here is the query again. I run this one time. Go for it. And let's see the live data. What you can see here, I hope it's large enough on your screen. What you see here is, here SQL Server has started my select statement. So select from customers and see what SQL Server is doing inside. We just only get one row back, and we are starting the function, we are completing the function, and then the statement will finish. If you have more than only one row, then clear data, you will see lots of these calls, and think about the problem we have here. So let's go for this. Rödel. This was German, stands for Rödeln. And here we go, and see what the problem is. I have now 10 rows, and come on, here we go. We start complete, and go, and go, and go, and go. And now think what happens if you have 75,000 rows. So every single time you see here, when the inner statement, so the function gets called, it consumes 425 milliseconds of CPU time, or 641 milliseconds of CPU time. And this is a nightmare. This is why the problem is, why these kind of functions are so problematic. Another point, when people are using Scala functions, is they want to use it as a predicate in the where clause. But experienced developers would immediately cry out very loud and say, oh my goodness, Uwe is an MCM, you don't know about searchable queries? I know, but this is a demo, you know? So what I'm doing here, I want to have just only the customers which have more than 5 orders per year for 2019, but only from customers from 1 to 10. I put this away, come on, clear the data, go for it, and execute. So the first thing what SQL Server is doing, it's filtering the customers lower or equal to 10, but then again, we have to go for every single found customer again, hey, do you have more than 5 orders? Yes or no, and again, and again, and again. And every single time this function is invoked, and that is a nightmare. That's something you don't want to have. So long story short, if you want to work with Scala functions and you are not in 2017, then always, really always use Scala functions inside of stored procedures to grab a value for a variable you want to use inside of your stored procedure. Otherwise, it is not a recommendation to use Scala functions for lots of data. For a little amount of data, no problem. But I would say, as long as you have, in the moment you have more than 10 or 100, depends on the complexity of your Scala function, hands off. So I hope this is fine so far, and we can go to the next thing. So in 2019, Microsoft had a great improvements of these Scala functions. You have seen that the Scala functions are not part of the set-based operation. They get calculated every single time it gets invoked. So what is the problem here? When we look to the function, I will go back for that. Yes, please. Scala functions. So when we look to the function itself, the point is that the function is, by the way, just only a select statement. So why not, from the perspective of Microsoft, hey, look into the function. Is it a set-based operation, or can I make it a set-based operation? And if yes, then transform my query, which is using the function, into a set-based query. What means when I go and now go to 2019 mode, execute. So we are now in. This is my original query. Let's go for it and see the execution plan. So SQL Server is going in parallel, pretty brilliant, absolutely what I was expecting. Everything is set-based. And now I have this function and I want to check, hey, is this function, what I have created, is it possible to transform this UDF in a so-called inlining function, which means that SQL Server will look into the function, say, hey, come on, it's so easy with you. I transform you to a set-based operation, baby. Yeah, and here we can check this. This is a new query, a new information in SQL modules. Here is my definition. And what is important for you is this one. Is it an inlining type? So it's turned on, yes. And can this function here be traversed into an inlineable statement in a row, in a set-based operation? So let's check this out. What I'm doing is I now recreate my statement, my X event. Go for it. Yes, it's done. And the first thing what I'm doing is I want to disable it again because I'm now in a 2019 mode. And I want to show, first of all, again, the before, how it worked. Come on, watch live data. So here we go. Again, disable T-SQL Scala UDF. Disable it now, and then we run again for 10 people or for 10 customers, and you see the call. Very easy, very simple. So far, clear the data. And when I look into the execution plan, you see exactly the same problem. Yeah, so we filter it, and then we come back with 10, and these 10s get executed the function. And now we are doing this here. So before, yeah, it's okay. So now I run this. Hey, come on. What's going on? Hey. Ah, I know what the problem is. Yeah. You see here that when Microsoft say, hey, you can use inlining, it is not always the best choice. Here we have a typical degradation. And what is the problem here? So now it's finished. And come on. Yeah, here we are. So you see that SQL Server did not have a function call in it. But the problem here is a really bad indexing. What is SQL Server doing? Think about the situation when you look to the query here. So SQL Server is looking into the function and say, hey, yes, cool, I can make it a set-based operation. And what is the problem here? We are coming back with 10 customers, and now for 10 customers, we make a full table scan, put the data into TempDB, into a temporary index, we aggregate them and get the data out 10 times. So inlining does not always mean, hey, come on, it's incredibly fast. That is the reason why we can, in 2019, if we're facing these problems, can use this query hint. Scala UDF inlining, disable it. So what I'm doing now is I speed it up in the way that I'm putting some indexes on it. Ah, come on, that was a problem. Yeah, come on. Here we are. Go. Now I'm doing the correct indexes on it. Hey, come on. It's a laptop. So I clear the data. Go again. And now I run this query again. Now I want to see for 10,000 rows before. Here's my live data. Clear it. Go for it. And it takes, and it takes, and it takes. Also, we have an index on it. You see that SQL Server was calling the function 10,000 times. So now, oops, that is Management Studio. Enjoy. It takes a few seconds. In the meantime, so normally if I would be in India and do the conference there, I would do a little dance for you. Now, unfortunately, I can't. So maybe I can tell you a joke. No, not so good. Oh, come on, please. Oh. You know, this is definitely a problem with the Management Studio. I forgot about this problem. But you can see here that the duration is way less. It's okay. It has decreased, but it's because of the indexes. But the problem is that the function is invoked 10,000 times. And when I do it this way, go for it, after it. So it took around 2 seconds. Come on. And now it is immediately done in less. So come on, it should be faster. Okay, 2 seconds, but look to this. So you see here that SQL Server is not calling the function again and again. Oh, come on. This sucks. This is live. So in the meantime, then we skip it and go over to the next. So Scala function improvements is SQL Server will transform the Scala function into a set-based operation, and that could be way faster, than calling a function again and again and again and again. So basic information. Recommendation is try to avoid scalar functions. So this automatic inlining, there are some basic requirements. It needs to be a select statement. You can use if then else, because that gets transformed by Microsoft into set-based operation with a case construct. If you have intrinsic functions in it, so get date, new sequential IDs, so non-deterministic functions, it won't get inlined. So it cannot, if you want to have that, for example, get date, no chance. You cannot reference to table variables, no order by, no references to user-defined functions, and you cannot use CTEs. Therefore, you should switch to table-valued functions. Multi-statement table-valued functions are great. They are cool. So they don't return a single value, but they return a set. So you see it here on the right side. It looks similar to the SCALAR function. It returns a table variable, hash t, and you then hand over your parameters, and then you start your statements or you start your doings. Insert into is the last thing that you put the data into your return table. And the statement you put at the last point is just only return, not return variable, but just only return. And that means stop the function. So the problem with these kind of functions is, and was especially, was that we had wrong estimates. The experienced developers of you know this problem. SQL Server before or equal to 2012, they estimated always just only one row coming back. From 2014 to 2016, SQL Server was estimating 100. That came with a new cardinal estimator, which was introduced first in 2014. So we had a little improvement. Instead of 1, it's 100. But to be honest, it was not really a good thing. And we tried to cover that. Also, experienced users know that with a recompile. But the problem with recompile is it doesn't work. So SQL Server was always thinking, well, come on, it's just only 1 or 100 rows. And that is a problem. And the problem here is that SQL Server, that is the calling sequence, how SQL Server will run or will execute the queries. And you see it here, why the wrong estimates are coming. We are starting with a select statement, and now at that point, here, SQL statement starting, SQL Server need to have an estimate for the return values or the return rows of the table valued function, exactly at that moment. But the problem is that the insert into the statement, into the table variable, comes after the complete execution plan has been calculated. So that's the reason why we are wrong. And then we come back with the bad estimates, and the query is running bad. Let me show you how this works. So first of all, I cut this, go away. Come on. So it's so cool. You know, I have a 16 gig full course, and this SQL Server Management Studio sometimes is hurting me so bad. And especially it's so annoying when we are in a conference. But the good thing is we have 20 more minutes to go. And yeah, then go for it. Then I switch over to this one here to follow up with this. So you see that SQL Server is putting the data into the table variable after we have compiled our plan. So that's the reason at the point at the number 141, SQL Server was estimating 1 or 100 rows coming back. And based on this, the post-compilation plan gets showed. I demonstrate it to you, promised. So with 2017, there was a great thing coming up. And this was called, or this is called interleaved execution. This is part of intelligent query processing. This is a new feature since 2017. And I promise you, Microsoft is putting all efforts on this intelligent query processing. The only thing what I can say is we are not at the end. We are just only at the beginning of it. And what you can see here is, in this example, is when I run the same query with 2017, you can see now, excuse me, that SQL Server is always estimating the exact number of rows coming back. What is the secret? How can Microsoft handle this? Well, related to so interleaved execution is an improvement which is just only for multi-line table valued functions. Interleaved execution means we take the part of the query that might be executed independently, which is the function, my table valued function, and what we're doing is we are executing it before we generate the execution plan for the whole query. There is one really little drawback. It will increase the CPU compile time, because what we are doing is we are compiling the query, two parts of the query, which means we have two compile processes. The first one for the function, the second one for the general query, which knows now the exact number of rows which are coming back. So this increased CPU compile time in a typical application, in a very typical application, is no problem. If you're dealing with applications, for example, you have 6, 7, 5, 10,000 queries per minute, then it definitely could be a problem. So test it well. Otherwise, it might be that you will get into trouble with that. But that is really, for normal basic applications, no problem. So see whether it's now okay. Okay, then I just go close it, no problem. Push it down, start it new. So the good thing here for that is you learn a little bit of German. SSMS wird neu gestartet, so it's executing brand new. So I get a new management studio. You know, basically I do normally not update my software before a conference. That was a hard lesson learned, but I'm coming back with the 18.4 again. Give me a second. I see this splash screen. Hey, come on. Oh, my CPU is increasing here. Here we are back. So, okay. Come on. So, we are back again, hopefully. Yeah, 2019. Well, see it live, color it in action. It's annoying, but lesson learned. Okay, so this is partitioning, has nothing to do. User defined functions. So let's go and start the demo. Multi-line. So that is a very simple query, very primitive. I just only call a create a function. This function returns a number of rows. So go into my demo DB. Here we go. So I just only do, what I'm doing is I have two parameters. The first one is the number of rows, and the second is just only an option to demonstrate to you whether it works if you recompile after you inserted the values or not. So I ask for come on, here for the number of rows, just only a number of rows, go for it, and here we go. So what you can do, instead of changing permanently the compatibility level of your database, you can use queryins. I want to use the query optimizer as it was in 2012. So select star, select 100,000 rows, no compilation, go for it. It works, okay, once again, and now, because now they're in cache, and see what the execution plan is. And this is a nightmare. This is a typical behavior, what you always will see. You see that SQL Server is calling the table valued function, and it goes into the order list, and please have a look to the estimated number of rows. It's just one. And the one is here, in this case, not really the problem, but the dependencies. I have an order by in it. An order by consumes memory. So we have a memory grant, and SQL Server thinks, hey, come on, it's just only one row. I take a 1 megabyte of memory for the ordering, and that leads to a sort spill in tempdb. Because SQL Server has calculated based on the 1, and that was way too less memory. So see how it works in 2016. In 2016, we had exactly the same problem. Because in 2016, SQL Server was not thinking it's coming back 1, but it was coming back 100 rows. And you cannot change it, whether you compile or not. So we have, again, the problem with the sort operation, because 100 rows is, come on, memory grant, 1 megabyte. It's cheap, based on the calculation. So here is the point. Let's go with 2017. Go for it. And what you see now here is that SQL Server is having a completely different plan. Why? First thing, SQL Server is now going in parallel because of the huge amount of data. Second thing is you don't see any sort spills here anymore because SQL Server, you see it here at the sort, there is no information in, hey, come on, we spilled to tempdb. Nothing happened. And when you look to the memory grant, you see that SQL Server has now 10 megabytes of memory here in this case. And the reason for that is that SQL Server now know that there are 10,000 or 100,000 rows coming back. And if you think, hey, come on, this one has cache now, and now we will always think it is 10,000 or 100,000. Nope. Whenever you change the parameters, whenever you do this, SQL Server will recalculate it. Get back 10,000 or 1,000. To be honest, this is the biggest improvement from my point of view, what I have seen from the intelligent query processing, especially if you focus on user-defined functions. Because you know what the reason is, what the point here is, I can now promise customers, hey, come on, if you're in 2019 or 2017, no worries, you can use multi-table valued functions. Again, that will give you a better improvement. It can give you. I know from one very close friend, he's a SQL expert too. It's Milos, I can't spell his last name. He's from Austria. He's working for bwin. They did a little trick because they wanted to have a nested loop operation. So therefore, they were using multi-line functions or table valued table variables. And now with 2017, SQL Server say, well, come on, you don't have to do it. I know the number of rows, and that could lead to different plans. How does it work internally? Well, let me show it to you in details. Let me show you the details of it. So first thing what I'm doing is I set my database to compatibility level 150. Make sure that interleaved execution for table valued function is set to on. And then I start again an X event, which I have prepared for you. And we go to the X events. Here it is. Here is my multi-line, and I watch live data. So I clear the cache. And the first thing what I'm doing is I first of all want to execute without interleaved. You know, I'm in 2019, and the normal estimates will be 100. So let's go execute this query. Here we are, 10,000 rows, and I look into the execution plan, go for it. And SQL Server is thinking that we are coming back with 100 rows. These 100 rows get sorted, and because of the 100, what we were thinking, we go into a nested loop. Because SQL Server is telling me, hey, come on, for 100 rows, just go and grab the additional information from the customers by each row. And that could be a problem. Now let's see how it works with Interleaved. Before I do this, I clear the data. And then we go back to the query. Hep. Now, come on. Oh, sorry. Yeah. Execute. I have to execute it. So here we are. It is way faster. Look to the execution plan. What SQL Server is doing, it's changing the plan. So we are not now going from a nested loop. It's clear 10,000 rows are up and coming into a merge join that is possible because of the index. And SQL Server now is coming with way more rows, 75,000 in this case, because I was requesting 100,000. Look what the live data is doing. So here is the point. I want to draw your attention to the important points here. So the first thing what you see here is, come on, let's do it here. So you see that an SP statement is starting, and please have a look what SQL Server is doing. SQL Server is, first of all, when we started, we are starting with the information, hey, come on, I have a situation where we can use interleaved execution. And what SQL Server then is doing, we first of all start to put the data into the table variable, which we have defined in our function. You see, it's a table function call. So what SQL Server now thinks is, or what we are asking for is, hey, what is the post-execution? So afterwards, after we have executed the function, the value, what did SQL Server do inside? So what SQL Server was doing very simply said, come on, I know that we have to go with 10,000 rows. When we finish this statement, so that means when we finish the table valued function, in that moment, exactly in that moment, we know the number of rows coming back. So what SQL Server here is telling me, that's just an important thing. So the event type 0 starts, hey, come on, I'm starting with interleaving, and here it's changing it back to 1, say, finished. We are now ready. We have executed it. And now what SQL Server is doing, after we have executed the function, then SQL Server is doing an amazing, a really amazing thing. Look to this. The estimated cardinality was, by default, 100. So come on, we think it's 100 rows. Excuse me. After the execution, the data are now in. SQL Server has done a correction and said, hey, come on. We are not having 100, we're having 10,000. And this leads then to a dedicated point where I'm coming on now here. Look to the SQL statement starting. Here at that point, after all the above things have been done, the query is running. The query now starts, but now we are coming with a new compilation. That means that we know the 10,000 rows, and now let's see what SQL Server is doing. Let's see, here is my SQL statement completed, query post-execution plan. This is the one what we are doing now, because SQL Server knows that we are now coming back with 10,000 rows here. That is so brilliant, and SQL Server caches it. And after it, when we have done, the rest is only a from the SQL Server system inside, don't worry about it. And after this, so that is the point where SQL Server can make you really cool, really good execution plans. And this is a so cool benefit. I absolutely appreciate it. It's brilliant. Yeah, and the biggest problem, or the biggest challenge here is, or the biggest benefit you have, whenever you change it, whenever you put another number of rows in, SQL Server will automatically run it, update it, and SQL Server now knows that the order list will come back with 10, with 100, and so on and so on. Absolutely. Absolutely super, super perfect. So this gives developers of table valued functions and multi-line table valued functions a huge, huge benefit, because now you as a developer can develop in a procedural way. You don't have to think about, oh my goodness, how can I put all these things in just one simple query that I will produce a inline user-defined function. Well, inline user-defined functions, I always preferred them, always. Inline user-defined functions mean that we just only put one single statement into your function. You see it here when you say create alter my function, customer year, blah, blah. It returns a table, and the table which gets returned is just only in this single return statement. The biggest challenge for developers, I don't mean database developers. Database developers can handle it perfectly, should handle it perfectly because they are thinking set-based. But if you're coming as a developer, let's say from Java, from .NET framework, and I do my kotao before in front of all developers because the different languages you all have to learn, and then on top database, T-SQL language, my goodness. Respect to you. So I can fully understand that people say, come on, how? I do not know how I can put everything in just one single SQL statement. Please let me do this in multi-lines. Now with 2017, you rock it. In inline user-defined functions, you can't do anything wrong because inline user-defined functions were never ever focus of improvement by the Microsoft team. Very simple rule. Inline user-defined functions are by default set-based, and it's like a view, or in other words, it is a view with parameters. So it's just only a single select statement, and there was no requirement for improvements of inline user-defined functions. You see it here. I put a with clause and I put an order by. All this kind of stuff can be inside these user-defined functions. So here are in a review the improvements you have by version. So we started with all three kind of functions in 2000, and with 2000 up to 2012, we had big problems. It was always single-threaded, and the estimated number of rows for multi-line table-valued functions have always been 1. That was a nightmare, and developers tried to work around by putting the data of the multi-line valued table into a temporary table and then run the query against the temporary table. Since 2014, the SQL Server team started with the improvements. SCALAR functions have not been on the focus, and they started with multi-line table-valued functions. They slightly improved the estimated number of rows. They increased it from 1 to 100. Was it an improvement? I would say no, it was just only to make a few developers happy, but it was not really an improvement. In 2016 or up to 2016, nothing has changed anymore. And with 2017, the first big improvements come into the game. Multi-line table-valued functions now can not only estimate your 100 rows or 1 row, no, they return the exact number of rows. But unfortunately, SCALAR functions are always single-threaded, so no more improvements here. And in 2019, on top of it, they brought inlining functions for SCALAR functions, which mean that we transfer SCALAR functions from a procedural thinking, row by row by row, into a set-based, into a relational model. And that was bringing a super great benefit to SCALAR functions. Try it out, you will be impressed by it. And in 2019, that was the only improvement. We are really excited to see what's coming next. So the only thing I know is that Microsoft has a big focus on it. They want to make the life of developers easier, and I hope with this session that you have seen that we are on the right track to make your life a little bit more relaxed in the way like you are maybe sitting now in your seat and watching this session. So I'm finished now, and I say a big thank you to all of you. And now I'm open for questions. Thank you very much for attending my session.
Thank you very much, Ruud. This was amazing. I mean, what a run through of user-defined functions, and I doubt how many would have gone into this kind of depth that you went into. So this was incredible.
Excuse me.
Hello, Uwe, am I audible? Yeah.
Yeah, I can hear you. I can hear you.
Yes, I was saying that the depth you went into was incredible. It was awesome.
Oh, yeah, thank you so much. Yeah, but I think when people are understanding what's going on behind the scene, then that's my impression, then they would like more to use this functionality if they see how it works internally, when they can explain it. And I will upload my session demos and my PowerPoint presentation so they can all replay it.
Absolutely. And let's see. Okay, community, a shout out for Uwe. Did you enjoy his session and the demos and everything that he talked about? The chat rooms are open. And you can type yay, Y-A-Y is yay.
Okay, yeah, so here is it. Yeah, I have to look here. Chat, yes,
Yes.
okay,
Look
yeah.
at all the comments that are coming in.
Yeah, I see it now. Yeah, I thank the audience. You know, without the audience, it would be half of the fun. Thank you so much, people. Thank you very much.
That's why I keep telling them to comment everywhere possible, but not everyone does it. It's a little bit sad, but then it's okay. That's how people react. So yeah, and
Yeah,
so
so I see a few Q&A, right?
yeah, you can go to the Q&A panel, Louis, and there are some questions there. If you
Yes.
want, I can help moderate, or you can just randomly read a few questions and answer them. We have 10 minutes or so, no problem, 10 to 15 minutes. Yeah.
Yeah, so what I will do now, I will go offline here. I will not share my screen anymore, but I promise to answer every single query what is now in the Q&A area, yeah?
All right, friends. So now Uvi is going to read out the question and then the answer. So these Q&As are more learning because then you're learning from your experience and your questions. So stay tuned as Uvi reads out the question and he will answer that. Uvi, please continue.
So thank you, Amit. It was a really cool thing, really. I liked it.
Um, Uvi, you can take the questions forward or would you like me to moderate the questions for you?
Excuse me, Amit, did you ask me?
Yeah. Shall I moderate the questions for you?
So I see the questions here. I have it here, the Q&A, and let's go from the let's see the first one. Yeah, why function is most required in SQL? It's only for filtration or other purposes? I don't understand the query, the question. Why
Yeah.
function is most required? Of maybe you mean for what, isn't it? Huh?
All right, so we will ask the gentleman out there, sir, ma'am, Northeast Rockers. Could you just rephrase the question? That will really help. Thank you. Okay, we'll move on to the next one. Any performance problem in passing table variable as argument to a function?
Yeah, so yeah, okay, I do. Yeah, well, if you put table variables inside into a function, it works. They can be passed in by read only. But the estimates for table variables have been changed with 2017 too. But I would not expect any drawbacks of it. No, the behavior is the same. It's the same as when you're working with table variables. So absolutely no drawbacks.
Okay, so we have another question. When should scalar functions be used? It has a lot of limitations, Rahul says.
Why functions? One moment. When functions returning table from a function, which one to be used? Cross apply or outer apply? This is one I'm seeing here.
Okay, so I dismissed the previous question. I will just kind of call it out. So the question,
Yeah, but let me answer this one. So let me just, that's very easy. Cross apply is equal inner join and outer apply equal to outer join, left, right. So it's okay. send, and it's done. Ah, okay. Can I send JSON with varchar max to UDFs? This is the one I have. Or what is yours? Where are you? Ah, okay. Then I go through this. What is trace flag and what eingeben? Predicate.
Uwe, shall I read out the questions? Will that be easy?
Plan. Sure, yeah, that is okay. So I'm just answering a few.
Okay.
I see here 15 open. So the first one is, can I send JSON with varchar max? Yeah, is it the same as you can see?
Yes, absolutely. You can carry on from there, no problem.
Yeah, okay. So then I answered this question. So that means that you want to parse JSON inside your function. That means you want to use it maybe in a table variable, in a table valued function for getting back a return statement. And as long as you, so I think, let me go back to one point. JSON, if you, I'm not so familiar with JSON, but I know, for example, XML, and you have XML functions, and you can use them in functions. So if you can use JSON functions in a typical select statement, then no problem, then you can handle it too. You can go with JSON, with varchar max, hand it over, and process it. Yes. So, and the next one is, where can we find the slides and resources of this session?
Yeah, so this will be sent to all the attendees post the event, no problem.
Oh, cool. Yeah, that is cool. So I hope that Sidesh had heard this. So that means I will send the my full demo and the PowerPoint to you back, and you will provide it then to the attendees, right?
Yes, absolutely, Uwe.
Perfect. So the inline functions in terms. So the next one is from Sva Anand. So in 2019, using multi-statement user-defined functions is equivalent to inline functions in terms of performance issues. I can say yes, it is. But keep in mind that inline functions will not work if you have non-deterministic functions inside. So when you're using, for example, getDate or anything which changes every single time, then it's not an inline function. Then you're back to typical multi-table valued function, and that will not perform better, or then you will not gain improvements from the inlining. So what would be the workaround? So let me say this here. What would be the workaround solution if I'm using SCALAR functions in my procedure? Well, it's from Anui. What would be the workaround solution if I'm using SCALAR functions in my procedure? Oh yeah, so as long as you don't use the SCALAR function in an output, then it's no problem, because then what you're doing in your store procedure, you say declare variable as data type, and then you assign the value which coming back from the SCALAR function. No problem, because it's just only one call. SCALAR functions will basically really hurt your performance when you call them in a when the SCALAR functions get invoked for hundreds of thousands of rows. So whenever you have the problem that SCALAR functions are called in an output, forget it, don't use it. Try to figure it out and put it better in a subselect query, just for example, to put the complete row set in a subselect, or try to make it a table valued function, but you can join with cross apply or without apply. But long story short, assignment to a variable with a SCALAR function works great. Do that, very simple. SCALAR functions in the select statement in an output or in as a predicate, try to avoid it. in terms of performance, are all three types of functions same now? So here I answer it, yeah. So the performance depends. So I would say if you have SCALAR functions which can be inlined, perfect, brilliant. But think about that you need to have that you cannot use some things like text, mtext, and all this kind of stuff, and deterministic. The SCALAR function needs to be deterministic. If SQL Server can do the SCALAR, can make the SCALAR function an inline function, then it's brilliant. It behaves the same as inline table valued functions. And the problem with the multi-line function is it is not the same. I would say it is definitely not really the same performance as inline functions, because in the demo you have seen that SQL Server has executed the table valued function before the execution of the own query. So it does mean that we have two call stacks, and that costs you a little bit more CPU because of two executions and generating of two execution plans, one of the interleaved sector and one of the query itself. So my answer to this is they behave different, and whenever you want to have best performance, try to use inline table valued functions. Northeastern, get it? Okay, then I put it off. From Sultan, where will this Rick session and presentation be posted? Okay, this is more for you, I think, guys.
Yes, of course. I already answered that. We are not sure about the recording though. We will get to know only probably in this weekend if recordings are available, but scripts and decks will be posted, and email will be sent to all the attendees.
Okay, brilliant, perfect. Then I have a question coming from Mithun. Can converting a SCALAR valued function to a table valued function and using it in cross supply offer better performance? Very short answer, oh yes, absolutely. Because instead of calling the SCALAR function for every single row, so it gets invoked, and if you put it then in a table valued function and put it in a cross apply, it's way better, because SQL Server will try to build a subset of the data, and then you can use it in the output. Absolutely brilliant. Try to do that. I promise this will be way better as the SCALAR function, definitely. Then we have any drawbacks of using new any drawbacks of using new features or functions in 2019? Yes, it can be. You have seen it in my demo here. When I was hoping, hey, come on, I have now an interleaved, or I have an inline function, and you saw that the system was suffering. But the problem with the suffering was not because of the function. The problem was a bad indexing, because what SQL Server wants to do is whenever it tries to put it into a set-based statement, then SQL Server needs to join it. And the big point, or the heavy hitter here, is the performance depends on what operator is SQL Server using for the inner tables. The inner table is the first table get called. Just give me an example, because it's a little bit difficult. Let's say you have a customer table, as in my example, and he wants to have the number of orders per year. So then SQL Server decides what table I take first. Will I take the customers? And then I go for every single customer, go into the orders table and count the number of orders. Here comes the problem. When SQL Server see that we only just have a small amount of customers, then it could be that SQL Server will go into a nested loop. That was in my demo here. So the nested loop means that we go for every single customer in the orders table and look for the number of data. But what happens if the outer query, so the customer orders query, is horrible slow, as it was in my example? It did a full scan, and here comes the problem. SQL Server did the full scan for every single customer. And that was the problem why it was so incredibly slow. So yes, there can be drawbacks of using this new feature, but you need to check it for every query in a separate way. So then my question is why function is most important. This is from Northeastern Rockers again. I didn't say that it's most important, but I know that lots of people are using functions because of reusability of code. That is the main purpose of why they want to use functions. That's the only reason. I always try to avoid it, but that means for most people having more typos to do. I'm creating.
I guess we are on time then.
Okay. Then we have to stop here.
Yes, kind of. We're taking a quick break because it's 3:15 India time, and I think not just one or two. You have more questions after that as well. So I guess we can ask the communities as we are doing with all sessions and speakers. We are telling them to put them in our forum, and maybe I will invite you and you can answer a few questions there.
Brilliant. I do. Yes. Okay.
I think that will be fine. Okay. So, right, friends, with this, thank you very much, Uwe, for your time and for your wonderful session. Loved the demos. Loved the way you took us through a complete journey of user-defined functions from very beginning till 2019. Amazing.
Thank you very much, Amit. It was a pleasure, and maybe we see you then in the chat room again. Bye-bye.
Absolutely. Thank you, Uwe.